Hey folks, in this video we're going to start our exploration of chemical reactions. First thing we need to do is understand the distinction between physical change and chemical change. Physical change is a process where the identity of the substance actually doesn't change. And this will include things like boiling points and melting points. We'll talk about that again in a few minutes. Chemical change, on the other hand, involves a change in the identity of the substance. So when we talk about physical change, we are talking about anything that doesn't, as I mentioned before, doesn't change the identity of the substance. So that means that the elements and the atoms don't change in a reaction. If we have compounds, they don't change in the process. So these would include a number of things, but among them, the ones that we see as chemists probably most frequently are what are called phase transitions. Phase transitions correspond to changes where it is the same substance, but we're undergoing a change in phase like solid and liquid and vapor. So phases are solid, liquid, vapor. To a first approximation. There are other types of phases that we won't get into in this conversation. So when you're talking about, for example, boiling, all right, boiling is a process where the substance changes from a liquid to a vapor. So, for example, we might be talking about water boiling at 100 degrees Celsius. It is still water. We have H2O molecules in the liquid phase, and those molecules then in the boiling process go into the vapor phase. They become gases. All right, so it's still H2O. It's a physical change. There's a phase change. Condensation would correspond to the process which is the opposite of that. So for example, we could write this H2O, and G for gas goes to H2O, and L for liquid there in parentheses. That's what we call condensation. Again, it's a phase transition. The identity of the substance doesn't change. Melting is the same kind of thing. So when we're talking about melting, we're talking about the solid, ice in the case of water, melting become the liquid. Again, it's still H2O. There's no change in the identity of the compound or the molecule. It's just changing its phase. Freezing, of course, is the opposite of that, where the liquid goes into the solid, and we could write it this way. That's a phase transition. And there are others, phase transitions as well, and some of which we may talk about a little bit later on. So that's physical change. Again, the point is we're not changing the chemical identity of the substance. All right, and so here is just an illustration which kind of demonstrates the process and the difference between the solid, in this case the solid, and the liquid. All right, what about chemical change? In the case of chemical change, we are changing the identity of the materials involved. We don't change the atoms. All right, the atoms themselves don't change, but we're changing the arrangement of the atoms, the compounds that they might be formed, that they might be part of. We're changing that, but it's still the same atoms. And so when we talk about a chemical change, we are talking about something still where the atoms don't change. It's just the arrangement of those atoms and the arrangement of the electrons changes. All right. And really, chemistry is a process which involves essentially the rearrangement of electrons when you get right down to it, to form different kinds of structures and different kinds of compounds. All right, so here's an example, one which is methane combustion. All right, and this just illustration just shows that. So we write a chemical reaction from left to right. So we have what are called reactants here on the left and products here on the right. with this little arrow here, if you haven't seen this before, indicating that we're going from reactants to products. So we start with the reactants and we end up with products. So methane combustion. The combustion reaction is one which involves a reaction with O2, which is oxygen that's in the atmosphere. So this little illustration shows the methane molecules mixing with O2 molecules here, represented that, like that. And it's generating carbon dioxide and H2O. So we can write this out. Methane, CH4, plus O2, these are our reactants, going to carbon dioxide and water. All right. We'll talk more about combustion reactions in another video, but basically, when we are talking about combustion reactions, we're talking about the rapid reaction with oxygen. All right. So this is an example of a chemical reaction because you'll notice that the compounds have changed. On the left side as our reactants, we have methane, CH4, and O2. All right, they react, and no longer do we have methane and O2. What we have is carbon dioxide and water. So we have noted here that the identity of the substance has changed. Now we'll note that the atoms are the same. All right, and we're going to talk about balancing these chemical reactions in our next few slides. But before we move on to that, let's just kind of go through a simple discussion here of these different types of processes and determine whether they're chemical or physical change. The first is frost formation. Now, frost formation is actually, we see this on a cold night, frost forming overnight. When you wake up in the morning, you'll see it see frost in the grass or on various surfaces when you wake up. Exactly what is that? Well, frost itself is just solid water. All right, well, where is that coming from? Well, frost actually is one process where the water vapor that's in the atmosphere is what then condenses to create, and it's actually called deposition, but it condenses to create the solid frost. All right, that's frost formation. Okay, now, is that a physical change or a chemical change? I'm going to leave that up to you. We'll talk about this later, but is that physical or chemical? What about food digestion? What happens when we digest food? When we eat something composed of, say, carbohydrates and proteins and whatnot, and those carbohydrates and proteins, etc., fat that we're ingesting then get digested, and the components of digestion then are stored in the body or used for various processes in the body. Is that chemical or physical? Yeah. Are the carbohydrates changing? Are the proteins changing? Are the vitamins that are in the food, are they changing? Are the various nutrients changing when you do a digestion process? Is that chemical or is that physical? All right? Think about it. What about match ignition? If you light a match, all right, you strike a match, you create fire. Well, that's a type of combustion, right? When you strike that match. Is that chemical or physical? All right? Perspiration, when you sweat. You do a good workout, you exercise, you sweat. The whole process is of sweating, and the reason for that is that the perspiration evaporates, and that actually cools your body through the evaporation process because it removes heat in order for that water to evaporate. That requires heat in order to do that. It requires energy. And that process then removes the heat from your body. Where's it coming from? So it helps to cool the body. All right? Is that a physical change or is that a chemical change based on what we've talked about there? And then finally in our list here, what about when you have a fork or any kind of, say, silverware, something like that, if you leave it for long periods of time without treating it, it tarnishes, all right? It forms a coating. Maybe changes the color a little bit. What's going on there? Is that physical or chemical? Some of the telltale signs of a chemical reaction actually would be that when things happen, is there's a color change. It's not always an indication of a chemical reaction, but frequently color changes will indicate that a chemical process is going on. Because a color change comes about by the creation of different types of substances. All right, so think about these, and later on we'll talk about whether these are chemical or physical changes. All right, now we talked about chemical reactions, going back, for example, to this one right here is an example of a chemical reaction where clearly products are different from the reactants. We've seen a change in the chemical identity. But one of the things that we mentioned, of course, is that during this process of reactants going to products is that the atoms and the number of atoms do not change. All right, so if the number of atoms do not change, that means we do something called balancing the reaction so that we have the same number of each atom on both sides, reactants and products. And we use coefficients that we're going to put in front of the various components of the reaction to balance it. Notice that we do not change the subscripts in the compounds formulas because those subscripts represent the composition of the compound. So we're not going to change those. We're just going to add coefficients. So here's a simple reaction. This is called a thermite reaction. And it is very simple. I have a video posted that demonstrates this thermite reaction. And so it's actually pretty simple. There's a reaction between this compound here, Fe2O3, which is iron 3 oxide. We're not going to be worried too much about names here. And this is essentially rust. So simple compound, iron 3 oxide reacting with aluminum. Again, pretty simple. All right, pretty simple reaction with aluminum here. But when we do that, it turns out that this particular reaction is one that generates a lot of energy. As you see, if you watch the video that accompanies this particular chapter in our discussion, that does generate a lot of energy with flames and molten iron. So it gets really, really hot. The reaction gets really, really hot, and the products are iron. So we start with iron oxide, but we end up with just iron. And it's so hot that the iron that's created is in the liquid form. It's molten iron. And then it's aluminum oxide. Now this is a simple reaction that's called an exchange reaction. It's also a reduction oxidation reaction, which we'll talk about in a future video. But what you'll note here is very simply that what we're seeing is a simple exchange here. The oxygen that was attached to the iron, associated with the iron, now becomes associated with aluminum, and it frees up the iron. Simple reaction. Okay, so here is the reaction. We're starting with the iron 3 oxide, reacting with aluminum, and we'll generate aluminum oxide and iron. All right, but it's not balanced right now, because if you take a look, let's take a look here. On our reactant side, we have 2 iron atoms, all right? But on our product side, you'll notice that I only have 1 iron atom, all right? Also, on the reactant side, I've got 1 aluminum, but on the product side, I have 2 aluminums. So I need to balance it, because again, in a chemical reaction, while the identities of the atoms don't change, we must make sure we have the same number on both sides. All right, so we use these coefficients. This one's relatively simple. We'll notice that on the reactant side, I only have 1 aluminum, but I have 2 on the product side. So I'm just going to put a coefficient of 2 in front of the aluminum. And then again, on the reactant side, I have 2 irons, but you'll notice on the product side, I have 1. So I'm just going to put a 2 in front of the iron. And now we're balanced. The number of oxygens, let's just check to make sure. We've got 3 oxygens on the left and 3 oxygens on the right. So we are balanced. So this ends part 1 of our discussion of chemical reactions. Stay tuned for more examples of balanced reactions in the next video.